Hey, welcome back to RamZland. Today I want to share with you the amazing chemiluminescence of Singlet Oxygen. Check this out. In this investigation, I'm using 30% hydrogen peroxide. I'm using a pool chlorinator whose active ingredient is calcium chloride, sodium hydroxide to scrub the gas. I'm using a separation funnel that'll lead to a 2,000 milliliter flask that leads to a second 2,000 milliliter flask. Start by adding just a small layer of calcium chloride on the bottom of your 2,000 milliliter flask. Next, connect it to your separation funnel and make sure the valve is closed. Next, pour 2,000 milliliters of distilled water to your second flask. Next, measure out close to 100 grams of sodium hydroxide. Next, add the sodium hydroxide to your distilled water and stir until the solution becomes aqueous. Once your solution of sodium hydroxide is aqueous, lead your flexible tubing into that flask all the way down to the bottom. The next step is to add a small amount of your 30% hydrogen peroxide to the separation funnel while the valve is still in the off position. Okay, now it's for the exciting part. I'm going to turn out the lights and we're going to zoom in to see the chemiluminescence of Singlet Oxygen. Check this out. Okay, we're going to slowly add drops of our hydrogen peroxide to our calcium chloride. Look for a red glow as the reaction begins. There it goes. Look at that. Okay, let's talk about that cool red glow that you saw. That was Singlet Oxygen. So normally what we breathe is called triplet oxygen in its grounded state, and it accounts for about 20% of the air we breathe. But when we add that 30% hydrogen peroxide to the calcium chloride, it releases Singlet Oxygen in that excited state. And as those molecules bump up against each other, their electrons give off photons of light that are exactly 634 nanometers in length. Remember, a nanometer is just a billionth of a meter. And through the light spectrum, that appears to us as the color red. Just an amazing reaction. Now let's talk about this part of the apparatus. Why did I have a solution of sodium hydroxide? Well, that's because this does release chlorine gas. And as that gas travels through this pipe into the solution of sodium hydroxide, it changes back into sodium hypochlorite, sodium chloride, and water, which is safe for us so that we don't breathe that chlorine gas. Okay, let's take a look at the chemical formula for this redox reaction. We start with the reactants calcium chloride, CaCl2, and hydrogen peroxide, the H2O2. If you look carefully at that chloride ion, it's being oxidized as it loses an electron, creating the product chlorine gas, Cl2. And if you look at the hydrogen peroxide, that oxide ion is being reduced as it gains an electron, creating the product water, H2O. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.